Hiya. Hiya. Hello, guys. Uh, Another problem. Determine the magnitude of the projection of the force of this force is already given. Sweet. In the direction of the cables AB and AC. So what do we need to do? You tell me. No. Okay, yeah, I heard something over here. Yeah, of course. You get the unit vector AB and dot multiply with F, and you get the unit vector AC and dot multiply with F. That's it. Plain and simple. Now, how do you find the unit vector AB? By finding the position vector and dividing that position vector by the magnitude of that position vector. And just don't multiply, that's it, all the time. Projection of the force in the direction of a line. Dot product of the force and the unit vector of the line. That's what you do every single time. How do you find the position vector AB? Position vector AB. Either you use coordinates, which is what you are used to do. So for example, what are the coordinates of this point? This is over the z-axis, and this is 8 feet, so it's going to be 0, 0, 8. And the coordinates of this point here, this is positive in this direction in y, in x is negative, I'm sorry, in this direction. This is x that is negative in x and positive in y, so it's going to be 4, but it's going back, so it's going to be negative 3 and 0 because it's over the axis. And this other one, which is what? In the x direction is positive 5 and in the y direction is negative 4. So it's going to be 5, negative 4 and 0 because it's over the plane. Once again. Now, how do you calculate the position vector AB? AB, tip minus tail. 5 minus 0, that's 5. AB and AC. AB, 5 minus 0 is 5. Negative 4 minus 0 is negative 4. And 0 minus 8 is negative 8. Okay, that's pretty much it. How do I find the position vector? The position vector is that. How do I find the unit vector? I have to divide this by the magnitude of itself. 5 squared plus 4 squared plus 8 squared. I'm looking to that side very much because I'm realizing that for this problem I took the solution manual and it's wrong. The answer is wrong in the solution manual. Yes. Not for the magnitudes, but if the problem is asking for the projections, definitely it's wrong. Another way that you can get the position vector, I covered this in the lectures. You can do something that I call running the vector. So you start from, instead of saying tip minus tail, you start from the tail and you run the vector from here to here, but parallel to the axis. Meaning, if I have to go from A to B, the first thing that you have to do is coming down 8 feet. Coming down means negative 8 in the k direction. Then you have to go to the left, and that is in y, right? So 4 negative, and then you have to come forward 5 positive. And you don't have to subtract coordinates or doing anything. If you don't know how to do that, that saves time. If you do it like that, save some time. But if you don't know how to do that, it's okay. You do it with coordinates and then you practice. For example, if I have to find the position vector, say AC in this part, I should subtract the coordinates of C minus the coordinates of A. and that is correct. So what are we going to do here? In reality, what I should do is that subtract these coordinates minus these coordinates. But if I run the vector, look, this is going to be negative 8, and then I have to go backwards 4, which means negative x, and then I have to go to the right 3, which is positive j. Now, if you subtract the coordinates, you're going to get the same thing. Look, negative 4 minus 0, negative 4, 3 minus 0, 3, 0 minus 8, negative 8. Divide that by the magnitude of AC, square root of 4 squared plus 3 squared plus 8 squared, and then we have everything that we need to have. If I want to find my result, which is the magnitude of the projection of the force in the direction of the cables, I multiply my force here times this, because this is the unit vector. And that will be the projection of the force over AB. And then I multiply my force here, dot multiply by negative 80I plus 30J plus 20K. Of course, the answer is going to be given in the units that we have here, which are pounds. I was already talking bad about the problem, you see. And if we want to do it here, the projection of the force over AC, you just have to multiply the force here, dot multiply with the unit vector. Remember, this is the unit vector AB, and this is the unit vector AC, which will be this multiplied by the force, negative 80I plus 30J plus 20K. And the answer will be in pounds. Now, if we do the first one, this one, let's see. That will be, the bottom will be 5 squared plus 4 squared plus 64, square root of that, square root of that. Square root of that. Okay. So then it will be I with, oh, you know something, I'm gonna keep this until the very end, which is gonna be easier. That number over there. So basically it's gonna be this times this divided by this times this divided by this times this divided by that. But this is the bottom, right? So I'm gonna just keep everything else together, and I'm gonna say 5 times negative 80, 5 times negative 80, minus 4 times 30, minus 4 times 30, minus 8 times 20, minus 8 times 20, and divided by this, which is the number that I have here before, divided by the answer I have before, and that's going to be 66.4, negative 66.4. So the projection of the force over the line AB is going to be negative 66.36 pounds. Once again, what does the negative means? The negative means that this force is going to be acting opposite to this direction. So it's going to be acting in that way. But anyway, the problem is asking you for magnitude, right? So the magnitude of the projection will be 66.36 pounds. That's the first one. Now for the second one, I'm going to do the same thing. I'm going to calculate the denominator first. 4 squared plus 3 squared plus 8 squared elevated to the 0.5. And I'm going to keep this number there in memory. And then I'm just going to multiply I with I, j with j, k with k, and divide it by that number. So it's going to be negative times negative is positive. 4 times 80. 4 times 80 is 320, but I'm going to put 4 times 80. And then positive times positive, this is 90, but I'm going to multiply 3 times 30. And minus times positive is minus. 8 times 20 is 160, but let's do it 8 times 20. And I didn't put my parentheses at the beginning. Yay, you're so smart. So I'm gonna put a parenthesis. That's a good chance to explain you in case that you haven't done it yet. If I put any number there, it's gonna erase the 4. So what you do is when you hit insert here, and now you put your parenthesis. You see, and it doesn't affect that. And then you go to the end, and you put your parentheses and divide by the answer that you had before. And this is 26.5. So the magnitude of the projection of the force F over AC, magnitude and value both are 26.5 pounds. I think that what the problem meant to do, or what this meant to do, is in the probably was asking in the direction of the cables BA instead of AB, because if it was BA, yes, this will be positive then, because the unit vector will be flipped accordingly. But anyway, this problem is correct in the way it is, and you know what the negative sign means. A lot of people don't know what that means, but you do. And thank you for watching, and see you next time. Have a good day.